Hello everyone and welcome back. Let's continue the foundation engineering class. Shallow foundation, estimation of settlement. Okay, today we are going for how to estimate settlement based on standard penetration test or standard penetration resistance. So if you do SPT, okay, how can you get amount of settlement of your shallow foundation from the N value, SPT N value? So for those who don't know what is SPT, please go back and see the chapter number 2 of this program. Okay, so let's go. SPT, standard penetration test. After doing it, how can you obtain the settlement of your shallow foundation? So we have several methods that can help us to obtain it. We have the Terzaghi and Peck method. In 1967, they proposed method to predict the foundation settlement of the foundation. So elastic settlement, as you know, the settlement that happens immediately and faster. The first settlement that happened immediately after loading the foundation. Okay. So for square footing, SE of foundation, the width of the foundation is 300 millimeter, between 30 centimeter. Okay, so they did that with like a square plate under same condition. Okay, so we have settlement of the foundation, SE of the plate. Okay, so what they found out is if you do this foundation of the settlement of the foundation is related to the settlement of the plate by this equation, this relationship. Okay, yeah, so you have to understand that we have square footing, okay, one apart, with the width of that footing 300 millimeter. The width of that footing is B, okay. That means like we have an actual foundation, yeah, and we have plate, square plate. They load it and measure it. It's for a settlement, okay, and they relate the settlement of that square plate to the settlement of the foundation with B. And here is the relationship they obtain. Okay, B, of course, it is the foundation width already, and DF is then the embedment footing. So in this equation, B is the unit of B is in meter. Okay, so the last term, this one, as you can see, there is DF here. This is to take account the reduction of in the settlement with the increase in the foundation depth. Okay, if it is too deep, then it will affect the settlement. And after the work in 1986, this reference proposed that we replace this value, the one instead of 1/4, we do 1/3, like this. Replace this one by 1/3. So it means if you replace instead of 4 here, if you put 3, the method will become the method of Leonard 1986. Okay, that's the meaning. So the value of settlement of the plate, SE plate, okay, you can see it here. We can obtain it from this graph design chart. Okay, this is like from this you can obtain the value of any other settlement. Okay, so you read this value as SE plate on this figure, on this design chart. Okay, and you can see here the value n value 10. If the n value is then 60, and here if the n value is 50. So you can see loose sun, because we are talking about in granular soil. Okay, loose soil, medium, dense, and very dense. So depending on the curve, you can see here the net applied pressure is here. It means the pressure, and settlement is here. That settlement is what you are reading, the SE here. Okay, so depending on the net pressure, I hope you remember what is net pressure again. Net pressure applied. Okay, it means the load that is coming on your foundation. Okay, so you read, for example, let's say your foundation, the net pressure of your foundation is coming on your foundation is 300 kilopascal. Okay, so it means here, and you have n value is like 10. Okay, then you can do this, read it, you come on this curve and you project it here. So it means your SE will be 30 millimeter. So you replace it here, 30 millimeter, and now your foundation you have on your actual construction site. If you are dealing with a square footing, because it need to be square, of, for example, 50 centimeter, okay, and 1 meter depth, 1 meter of B, the width of your footing, and embedment is 0.5, then you can easily predict the settlement of your foundation using this. Okay, the problem now you might have is that you can see that here the n value, SPT value, we don't have like we don't have it continuously. We have 10 here, we have 30 here, we have 50. So what happens if you have, for example, 20? So if you have 20, you have to imagine a line between 10 and 30, something like that. Okay, you draw it, and then you can read depending on the net pressure coming on your foundation. For example, if it is 60, you use it is 600, you use 600, you project, and you read here the settlement. I hope it's clear. So what now is the, at what value of n value you are taking, you have to consider. What I mean is, when you are doing the SPT from the ground surface to the depth you want, the SPT is changing. Okay, the SPT profile is not like a straight line. Okay, so we need to know, okay, which value. We will talk about this later in the next following slides. But as you can see, this equation is applied for square foundation only, but it was proposed using square foundation, but you can extend it, apply it to rectangular foundation and strip footing with caution. Okay, normally it should be, the settlement should be larger if you are using strip footing or a rectangular foundation, because it can be like and these are a little bit like taking more places than square footing with the same B. Okay, but anyway,